Hello, everyone, and welcome to another episode of the Services in the Age of AI podcast from CSA at the University of Cambridge. As you know, I'm Gautam Jha. I'm leading research on the strategy theme within CSA, where I'm exploring AI enabled digital service transformation. And today I'm very pleased to be joined actually by two guests. One is Stefan Vanassche. I hope I'm pronouncing that correctly, Stefan, the Chief Commercial Officer of Catalyx. Stefan has a proven track record in senior commercial positions in a global consulting environment with a particular focus on regulated manufacturing settings, such as in the life sciences sector. And I'm also pleased to be joined by my colleague Bingxin, who is a research associate working at the CSA. And her work actually examines AI agents and service delivery in such clean manufacturing environments, such as semiconductor production, where precision, reliability, and process control are central. So, great guest to actually discuss the theme of our podcast today, which is on what does AI enabled services mean in high stakes manufacturing. So, we have two interesting contexts to discuss over here. One is, of course, Stefan is going to bring the perspective from a regulated environment perspective, and Pingxing hopefully will bring a research perspective from, precision manufacturing's perspective. So before I get into AI enabled services and all the details, it'll be great to actually know our guests a bit more personally. So Stefan, for people who know you through your professional work, what is one thing that they probably don't know about you?
Good question. First of all, Gautam, thanks for pronouncing my name so nicely because in Dutch you say Vanassche, but you
Okay.
pronounce it like in a very Italian way, Vanassche, which sounds like very with a flair. So I love it.
Thank you.
Um, yeah. So just personally, I mean, I'm the father of three lovely daughters and I have a beautiful wife and I have two dogs. That's all personal stuff. But the one thing probably nobody knows about me is that since a long time, I one of my hobbies has always been DJing.
Oh,
I've done that since I was a youngster, but up till today, because people know that I'm doing that, they ask me from time to time. And, the reason I bring this up is just because obviously also in that space, AI is doing a lot these days. So, just a fun fact about myself.
very, very interesting. The first podcast that I recorded was with the Chief Product Technology Officer of Yum Foods, and he said that his personal passion is stand-up comedy.
Oh, there you
And
go.
and he said that he wants to actually use AI to write a set for him. So interesting mix from DJ to
That's
stand-up.
interesting. I heard actually the same from an actor that I know, and he said he tried the same, and he said it was extremely poor. That AI today doesn't have any sense of real humor. Not
Interesting.
sure why. Well, yeah, there's probably some guardrails put around it, which makes it less funny. But anyway,
Yes. So, Bing Singh, same question for you. What is something that people may not know about you?
Um, yeah. First of all, thank you very much for inviting me. Join this very valuable talking. And I think one thing people may not know about me is that although my work at CSA focus on AI-enabled services and service research, like customer trust and the like how to understand the customer trust formation process and mechanism, something like that. But my original research background is very much rooted in industrial systems and reliability engineering. So I started from problems such as anomaly detection, degradation modeling, and predictive maintenance. So back into this background, my key question is not only like whether AI model is accurate, but whether it can actually help people to make better operational decisions. So I think this background kind of shaped the way I look at the AI services research today at CSA. Because I'm always like interested in how AI can move from being a technical tool to becoming something like can support the real human decisions, especially in the complex services and the manufacturing context. So that is pretty much one thing I like to share. Yeah.
Brilliant, fabulous background that you bring, Bingxin, and that's why we'll be interested to know your insights in this area. But before we get into some of the nitty-gritty details on AI, it'll be good if Stefan, you can share how and why is high stakes manufacturing actually different, because most manufacturing firms have been talking about digital transformation services based on value for a long time, and AI actually brings sort of a new level of possibility but also some complexity. So from your perspective, what actually changes? And but before that, please give a background of why this high stakes manufacturing is different in the context that you've seen.
Yeah. So if and by the way, maybe it's important to mention as well that so with Catalyx, where I work as the chief commercial officer, we work mainly for the life science industry. So the a very highly regulated industry, and what makes the use of AI, and then even more specifically the AI that we built with Catalyx, which is not like the typical LLMs that everybody knows these days, but we use basically machine learning in machine vision applications in the life science industry. So as that touches manufacturing in this highly regulated industry, it means that the systems to put them in productions, they need to go to a regulated validation process. So you cannot just put a system in production in manufacturing like that. It needs to go through this whole regulated process. And especially there, the industry is still learning as we go on how to deal with something which by nature non-deterministic, and then how do you connect that with validation. So that is what makes it very different, I would say, probably as one of the most important elements what is specific to this industry.
So from your perspective, Stefan, what actually changes when firms start offering AI-enabled services in this context from traditional products or services-based contracts? Like I
Mhm.
remember when we were speaking earlier as well, you were mentioning about if you were in this industry maybe 20 years back, you would be trying to sell the cameras or the equipment.
Mhm. Mhm.
But now that that equipment brings machine vision and AI-enabled services, what changes basically now?
Mhm. Well, again, from the perspective of Catalyx, what we found in the products that were building, the very specific solutions that we're trying to solve, is that first of all, with AI you can solve much more complex problems that what you could do with traditional machine vision, which is basically a very old discipline. And you apply traditional deterministic programming, which is basically comparing a good image and the pixels of an image with how it's supposed to be, and then you decide if you do a reject or not of a product, to put it simply. um, with AI, we are able to solve problems in this industry that we could never have solved with traditional machine vision because of the complexity. So one of these problems that we are trying to solve, and where we're a front runner in that industry, is a very important problem in life science manufacturing, is line clearance, which is basically the process where you need to check that there are no rogue components from a previous batch left on a production line, to avoid any mix-ups with your new batch, which could have very severe consequences for patients, but also for the company, as it might call like a very expensive recall of a batch. So what we are building is, first of all, an AI model which is able to interpret images that we take from this production line during the line clearance process, to do checks if any of these rather small row components are present on this manufacturing line. So you should picture a line that could be up to 100 meters long with all difficult to reach places. You have cameras on all these places, but it's also a very complex environment where there is all kinds of shadows, reflections, complex scenes that need to be interpreted, and find in there very small components that should not be there. Not only that, you need to, for the system to be able to bring the ROI that the industry is looking for, first of all, there is zero acceptance of having false negatives, which means that basically you would not see that there is a row component where there is actually one, which is very bad. So there is zero acceptance on that. But then as well, you should avoid that there is too much false positives, because then you're basically, creating overhead for the operators, because you're making them do checks which they actually shouldn't do, because there is nothing at that spot. So building that type of model that can deal with all this complexity took us about 5 years. And just because it's so complex, what you need is basically a partnership, and that's what we started to do with some of our key customers, which are like top 10 big pharma companies, where we jointly developed this AI model, because you need all this industry expertise knowledge, which comes obviously from the side of the customer, and get that in these models. So I think the point that I'm trying to make is that because you're involved in much more complex challenges that you're trying to solve with these AI based solutions, is that getting that very deep industry knowledge into your AI solutions is critical for this to work. And that's where much closer collaboration with your customers is required.
Excellent. And that's a challenge, Bingxin, from your perspective also. In there are some themes I think I see that they resonate basically, but in the precision manufacturing context, such as what you have seen from the semiconductor industry, what makes AI enabled services particularly challenging to deliver?
Yeah, I think from what I have just listened from what Stefan has observed from the industrial side, I would say that there are still a lot of challenges, and those challenges are quite highly aligned with what Stefan just says, like in their manufacturing line, like they have like zero tolerance for the false negative, and at the same time, zero tolerance for the false positive. And this is exactly the same for the high stakes manufacturing context. And also, because of this kind of high stake manufacturing context, such as semiconductor manufacturing, one big challenge here is that the customers or the users, they do not fully trust AI by default.
Mm.
I'm saying that although like the general customers do not trust AI, it is extremely more severe when we come to the high state manufacturing. Yeah, this is because the cost of run decision can be very high. Like if we have some zero we have some false negative or false positive, we have to record the full batch of the production products. as have been mentioned by Stefan. So people naturally want to understand why the AI makes such a recommendation. They want to understand how the AI come to such a conclusion. They do not want to just receive one conclusion without some detailed mechanism behind how this conclusion is formed. So like they want to hear the evidence the AI uses and whether the decision is reliable. And the measurement of the reliable is also very important for the customers. So the challenge here is not only technical accuracy, but also how trust is formed during the interaction with the humans and the AI system. So that is basically, I believe, the first challenge. And also, it reminds me of the second challenge, which is that the knowledge we need for the decision making in the AI system is very fragmented. Like Stefan just mentioned, if they want to detect the product that remaining on the production line and remove the product so that the product from different batches won't be mixed together, the first information they need is machine vision, and they also need the expert knowledge about how to detect this kind of anomaly in the figure. So there's like only two sources of information. It's already a very complex problem. But in the high-stake manufacturing, it's even more complex because the useful information may come from sensor data and the equipment logs and the process documents, images, and also maintenance records, and also the tacit knowledge of the experienced engineers. So these sources are very different in format and often sit in different places. So this leads to one key challenge is that how to integrate structured data, unstructured data, and documents and expert knowledge into one coherent decision-making framework. Yeah, that is basically the two top challenges I can think of right now. Yeah.
Okay, and that aside, because Stefan, you wear the a commercial hat, with all of these challenges, sometimes even the credibility being questioned, the lack of some of the expert knowledge as well. How difficult actually is it to then sell this commercial value from AI enabled of enablement? Because some of these may not be immediately visible. If something goes wrong, it's immediately visible, but if everything is going smoothly, then the value sometimes may be like it's not really visible.
Yeah. Well, if I look in Catalyx and the services and solutions that we provide with Catalyx, I think you know the ROI of what we do is quite measurable. So, which is different than, for example, if you say like, I'll build some agents in an ERP or a CRM system, and it can automate some tasks, but to measure the ROI for that is probably not that straightforward as the problems that we're solving with the Catalyx, and especially the example that I gave, for example, with this line clearance solution, because it is very measurable actually. What we're doing is, so the key challenge that a lot of these companies face is that their OEE, so the efficiency of their equipment, is very low in the life science industry. It is, and Bingxin, you will know that in semiconductors it is typically high, where in life science industry it could be in the 30s on average almost. So very low OEE. And an important driver for that is the time it takes to do line clearances. So if this solution that we implement, if that solution is able to materially lower the time it takes to do line clearances, the impact and the value that brings is immediately measurable. And then especially even more in products that they have with unlimited demand, it's it has a very material impact. So measuring the ROI, and like if we look at the solutions that we implement, typically in the ROI models that our customers use, which are very stringent, they would have a return on investment typically within 2-3 years from this solution. Um, uh, the other element, which is less measurable, but which is very important to customers as well, is that this solution it can avoid, like, major disasters like recalls. So the cost of that could be enormous, and it's obviously it's less easy to quantify that, but still that's also an important element in the calculation of ROI. So in summary, I would say, in the Catalyx world, Gautam, I think there is the advantage for these type of systems that what we do is very measurable, and it's less difficult probably than in companies that sell, more like agentic solutions, where you solve like a part of a problem, but then, you know what does that exactly mean in terms of cost and savings that you're doing by having that agent, if that makes sense.
No, no, very, very, very interesting, Stefan. And just to add to that, what just Bingxin mentioned on the challenges, even from the other industries as well, where the knowledge is sort of fragmented, basically. So whether you're embedding that into a process workflow, that's, as you said, is much more difficult than, let's say, something like in the Catalyx offering, it's a bit more directly attributable to what
Hmm.
the ROI is going to be. So now, let's for now assume that this everybody agrees on the value. The boards are, sort of ready for some of the AI investments that we are seeing, and actually they have been much more happy to invest, even with a leap of faith. I've seen at least 2 years back. But now they are asking more and more questions. And one of the biggest questions, one of the biggest challenges that I'm also observing is that, is the enterprise actually AI ready over here? And how do we actually then get the enterprises to become AI ready, to sort of integrate into those workflows? Or even in the case of Catalyx, how do we then integrate the solution in such manufacturing enterprises?
Hmm. Well, the pharmaceutical industry is a very conservative industry for good reasons, obviously, as it has impacts on the health of people. Um, so, like I mentioned in the beginning, um, there is in these type of solutions, there's a lot going on in regards to applying AI in validated manufacturing environments. I'm actually joining a conference in Boston next week, which is specifically on that topic. So I would say, um, specifically in manufacturing in pharma, we're probably at the very early days of readiness. There is definitely, we're coming from, there's probably no match between a validated environment and something which is non-deterministic, and we will not do this. Where I think where we are today is that there is definitely appetite, and the industry sees value in these type of systems. However, we're still finding out, as we say, between industry regulators, vendors, on how to deal with this new concept of putting solutions which do have value but are non-deterministic by nature into validated environments. And I do believe that we'll get there, but it'll take probably still a few years before the industry will, get to higher maturity levels for that. On the other side, I'm also on the board of a company called BizApps, which is providing CRM, ERP services to mid-sized companies. And in that environment, you also see that, especially when you're not in the big corporations where there are teams working on trying to find out where the value is with AI, for these companies in mid-sized and smaller companies. It is, I would say, maturity levels at this moment are very low. There is interest for sure, because everybody is talking really about AI. Up to my mother-in-law, my father-in-law, they're in their 80s, but everybody's excited about AI and what it can do, because it is a bit like magic, right? In the end, if it really works. But there's still a big gap, I think, between the story and the promise, and then finding out what can it actually really solve for you, and how much does that actually cost to get it to a point where it's really working, beyond like a proof of concept.
Yeah, and this is where those are the type of challenges which I know Bingxin is it keeps her awake every day. That how can such setups, she's building very very complex multi agent setups. So the type of agents that you're exploring, Bingxin, how do you think these will get actually implemented in such contexts which are so risk averse, like Stefan just mentioned, that they are looking at, they are used to deterministic outputs, and sometimes there is a bit of fuzzy and non-deterministic outputs as well which are available from these setups. So how
Yeah.
can they implement these agents, Bing?
Yeah, I would say this is a very interesting question because this is almost the everyday question I'm thinking in my mind. It is not very difficult to build this multi-agent. What the most difficult part is how to like implement these AI agents into the context, and especially in the high-stake manufacturing context. So I think we first need to distinguish different levels of AI solutions. Like for the basic large language model applications, such as summarizing documents or retrieving informations, and this kind of applications, their implementation is not very difficult because they have been embedded into the existing workflow. But for the more intelligent agentic AI that you have said, which multiple AI agents orchestrate together with each agent doing their own job, and together they complete a very complex task. So this kind of AI system is very difficult to implement. So implementation is much more challenging. And also in the high-stake manufacturing, such systems always need to be conduct a very rigorous test with the stakeholders. And then during the test with the stakeholders, we must demonstrate very clear value. So after demonstrate the very clear value to the stakeholders, we can probably deploy these solutions into the real production line. Yeah.
Okay, thank you. And finally, basically, one of the and we touched a little bit upon this, but the impact of risk and reputation is very very high in today's world. Whether we talk about the life sciences industry that you're part of, Stefan, and even the semiconductor industry, because a little shortage of semiconductors, as you can see, impacts so many consumers, and of course life sciences, we can't even go to the type of risks that are presented in that industry. So, in such industries, of course, there's a promise of ROI, and you mentioned OEE as a metric. But still, how can businesses actually look at these type of challenges related to risk and reputation, and not just risk and reputation? The risk of, for example, just recently you heard the news of Fable 5 being pulled out from US. So that so the other countries who may, let's say, if somebody started using Fable 5 into their production lines from cloud, and it's suddenly disallowed, and the impact now can be quite severe if they start relying on such models. So how should businesses tackle these risks in such industries?
Yeah. So again, like on with Catalyx, so first of all, we in these type of applications we don't use like the available big LLMs. So that is not that is not something which is part of the solutions that we built. However, of course, like I said, the you know the thing with or the problem to avoid with the solutions that we provide to these customers is that you never allow for a raw component to pass your system. That is the biggest risk. If the system fails in that, that's a major issue. So first of all, we've brought the model to a point that after several, a huge amount of tests, we are able to guarantee to our customers zero false negatives. That is one thing. So then, obviously, there is the whole regulated element in this industry where before you go into production, these systems need to go to regulated validations, and the industry is working on that, on how to deal with that specifically for AI-based systems. So that is something which is specific to this industry. Then in our solution itself, um, what we also guarantee is that once a system is then validated, obviously it lives in the real world. So you have validated something, but then what if a light bulb get changed in that production hall? That means other lighting conditions, and it impacts basically the results of your model. So we have built in a mechanism, we call that self-healing, and it allows basically for operators as they go and they spot, for example, due to all kinds of changes that there is a false positive, for example, they can then flag that to the system. And then we have also, so that's one human in the loop. But then we before we feed that again into our model to basically retrain it, we have a second validation by a team leader who will do a double check that what the operator found to be a false positive is actually a false positive. Because you could as well, if and we saw that quite often actually, that an operator flagged something as this is a false positive. However, when they did a double check, there was actually something there that the operator didn't see. Okay, so if you would feed that immediately into your model, you would actually make your model worse. So what we build in is basically two humans in the loop before it goes back in our self-healing system. So those are all kinds of steps that we are taking in our specific solution to make sure that we manage that risk as much as we can.
Interesting. Only yesterday we were having a conversation with a very simple battery maker, and
Hmm.
they were talking about this, that it may seem that our batteries are a very simple utility, but if when they go, all of these sensors and many other equipment, stops working, and it's so much linked to these type of solutions, that it can be of quite a consequence to their customers.
Hmm.
Basically, they wanted to understand how to shift from being, a utility to more like a proper service and have an
Hmm.
experience with using some of our research. So when I hear that light bulb example that you gave, that a small light bulb change can have such an impact.
Absolutely, yeah, yeah.
Yeah, and I'll remember that example when we discuss this with the battery people
Yeah,
uh,
yeah.
as well. And Bingxin, so how from an, because of course you are working with the agentic world, which is using a lot of LLMs. So how do you think we should safeguard the agents that you build, and when if they get deployed into such environments, precision engineering environments, or the regulated environments?
Yeah, very interestingly, although like we are thinking about this question from two different perspectives. Like Stefan is thinking of this question from the industrial perspective, and I'm thinking of this question from the research perspective. The answer and the solution here is like very similar. It's like our suggestion is also to design the system with the human in the loop and the human on the loop, basically to provide the human supervision to the AI solution. So that is to say the AI can analyze data and recommend some actions, but a critical decision should still be reviewed and approved by human expert before implementation. And this is especially important as like Stefan has illustrated in the production line. It's also very important in the precise manufacturing because a wrong decision may affect the safety, the compliance, and the reputation of the whole company. So yeah, basically the conclusion is exactly the same conclusion: human in the loop, human on the loop. Yeah.
Yeah, and I also call it human on the hook.
In the end, always there's always a human on the hook. Yeah, very true.
So thank you so much. This has been such a fascinating conversation, and I learned so much in this conversations. Thank you, Stefan and Bing Singh. We started by understanding some of the challenges, some of the solutions which are not all necessarily cemented. They are actually in the process itself. So yes, these areas are quite closely connected, as you mentioned, Bing Singh. I like that analogy as well. That from both perspectives, we are concluding in the similar direction. So thank you everybody who's listening to the Service Systems in the Age of AI podcast from the CSA. And of course, if you enjoyed this episode, I'm going to start saying the same thing which I've heard from so many influencers: like, share, subscribe. So please do that to this series, as well as we start continue exploring how AI is adopted in organizations. So until next time, thank you, everyone who's listening to this podcast.
Thank you for having